Question number 28. Test the indicated claim about the means of two populations. Assume that the two samples are independent, simple random samples selected from normally distributed populations. Do not assume that the population standard deviations are equal. Use the traditional method or the p-value method as indicated. If we scroll to the bottom of the question, it says to use the traditional method for hypothesis testing. So we're using traditional method. So no p-values in this case. A researcher was interested in comparing the salaries of female employees and male employees at a particular company. Independent simple random samples of 8 female employees and 15 male employees yielded the following weekly salaries in dollars. We can definitely see that the standard deviations, rather the variances, are unequal. And the reason why I can make that assumption is because there are a lot more male employees that are being sampled than female employees. Anyways, use a 0.05 significance level to test the claim that the mean salary of female employees is less than the mean salary of male employees. Use the traditional method. So we want to test the claim that the mean number of female employees is less than the mean number of male employees. I want to highlight that and put that in red. The word less than. Because less than gives us a direction of our test. Before I continue, I want to label group 1 as females, or just female, I should say, and group 2 as male, to give your reader or your professor who's grading your exam an idea of which statistics goes with which group. So every subscript with 1 belongs to female, so those are female statistics, and every subscript with a 2 belongs to group 2, which is males, so that's male statistics. State the hypotheses. Okay. We have the null hypothesis and the alternative hypothesis. The null hypothesis states that there is no statistically significant difference between the means of both groups. Because there will not be a difference between the means of both groups, not having a difference is the same thing as saying that the mean of the groups will be equal. So parameter 1, which is mu1, the overall average for female salaries is equal to the overall average for male salaries. That is the null hypothesis. Some people also write it as this. This is an alternative way. Mu1 minus mu2 equals to 0. Because if there is no difference between the means of the groups, that means the difference is 0. Now, when it comes to the alternative hypothesis, we're trying to test the claim that the mean salary of female employees are less than the mean salary of male employees. So that is going to be mu1 is less than mu2. And that is the claim. And an alternative way to write this, the alternative hypothesis, is mu1 minus mu2 is less than 0. But I'm going to keep my null and alternative hypothesis written in this form that I'm highlighting in the yellow highlighter. This is the form that most of us is familiar with. All right, let's move on. We want to find the critical value and state the number of degrees of freedom. First thing is first, let's indicate our direction. The direction is one tail to the left. Or you can just say left tail. But I like saying one tail to the left because it lets me know when I find the critical value on my t-distribution, I'm looking at a one tail. And because it is to the left, the critical value should be negative. The alpha in this case is going to be 0.05. And then we must use the smaller degree of freedom. So let's find the degrees of freedom for both groups. To find the degrees of freedom for the first group, it is the sample size of group 1 minus 1. And to find the degrees of freedom for the second group, it is sample size 2 minus 1. Now remember, we have a total of 8 female employees and 15 male employees. Because we have 8 female employees, the degrees of freedom for group 1 is going to be 7. And because we have 15 male employees, the degrees of freedom for males or group 2 is going to be 14. Because we must use smaller degree of freedom, we're going to use the degrees of freedom of 7. Now let's go on that T distribution. One-tailed 0.05, degrees of freedom 7 to find the critical value. One-tailed 0.05, degrees of freedom 7. But remember, because this is a left-tailed test, the critical value will be negative 1.895. Now, I know in the answer key is going to give you a different critical value. It's just that solution is incorrect in the answer key. This is the critical value for this test. Now, we want to compute the test value. Because we're using the traditional method, we do not have to compute the p-value interval in this case. So I'm not going to go over that. If you want to see how the p-value interval can be conducted, just review the question before this one. Because we're comparing the means of 2 independent groups with the assumption that the variances are unequal, we're going to be using the independent samples t-test formula. And we're going to use our sample statistics provided to us from before. So let's scroll back up and let's zoom out to get those values. So t is going to equal to the differences of the sample means. So that's going to be $705, $375 minus sample mean 1, which is 817.067 minus. Remember the purpose of hypothesis testing. We're testing our claims under the assumption that the null hypothesis is true. What does the null hypothesis state between the mean of independent groups? there is no difference between the means of independent groups. Because there are no difference between the means of independent groups, the difference is 0. Mu1 minus mu2 is 0, as stated up here. Divided by the standard error, which is going to be the square root of sample standard deviation 1, which is going to be 183.855. Zoom in a little bit better. That is squared. And that's going to be divided by sample size 1, which is 8 females, plus we have a total of 15 males. And the sample standard deviation for males is 330.146. And that's going to be squared. Let's open up our calculator and start calculating. So the top, 705.375 minus 817.067. That's negative 111.692. 183.855. Square that. Then divide that by 8. Let's take 3 numbers after the decimal. That's going to be 4,225.392. Plus, let's do the same thing for the next fraction. That is going to be 330.146 squared. Divide that by 15. 7,266.425. Write this a little bit more neater. Negative 111.692. I'm going to do the entire square root at once. So square root of 4,225.392 plus 7,266.425. And that is 107 point. I'm going to take 4 numbers in this case. 1999. And let's round our final t value to 3 numbers after the decimal. We know it's going to be negative. So negative 111.692. Divide that by 107.1999. And that's going to be negative 1.042. That is our test value. Step 4, make a decision using the traditional method. So we're going to draw our bell-shaped curve. That's a better version. I like to put 0 in the middle. And we're going to place the critical value on the bell-shaped curve. The critical value was, zoom in a little bit, negative 1.895. And then we're going to shade into the tail region of this distribution. If the test value falls in the shaded area, we're going to reject the null hypothesis. If the test value does not fall into the shaded area, do not reject the null hypothesis. The test value that we just computed was negative 1.042. And that is going to fall on the left side, but it's not going to fall within the critical region. It will fall somewhere right here. And because it falls outside of the critical region, you do not reject the null hypothesis. That is the decision that we are making. Do not reject the null hypothesis. And because we did not reject the null hypothesis, to summarize our results, we state that there is not enough evidence to support the claim. That female employees earn less than male employees. And there you go. That is it for number 28. So, quick review of everything. I'll catch you in the next one. Take care.